Binomial theorem. Question number 1. In the expansion of 1 plus x times 1 minus x power n, the coefficient of x power n is. So let's write the general term of 1 minus x power n. So 1 minus x power n has a general term as tr plus 1 equal to ncr minus 1 power r x power r. Now, here we have 1 plus x times, since we need coefficient of x power n, so here there is already x power 1. So from this we need x power n minus 1, and for this 1 we need x power n from here. So let's write those two terms. So ncn minus 1 power n, and this will be x power n. And next term will be nc n minus 1 minus 1 power n minus 1 times x power n minus 1. So when x is multiplied to x power n minus 1, we will get x power n. And when x power n is multiplied by 1, so it will be x power n. And our purpose is to get coefficient of x power n. So we can write the coefficient. It will be n c n into minus 1 power n plus, from here, nc n minus 1 minus 1 power n minus 1. So from here we can take common minus 1 power n. So what we can do, we can multiply by minus 1 and divide by minus 1. So this will become minus 1 power n, and hence we can take common. So we write it minus 1 power n. Then we will be left with ncn. So ncn is 1, and here this minus sign will be used here. So minus ncn minus 1, and that will give n. So this will be our answer, minus 1 power n within bracket 1 minus n. Now consider second question. We are given if Sn equal to sigma r equal to 0 up to n 1 upon ncr, and Tn is sigma r equal to 0 up to n r divided by ncr, then what is the ratio of Tn to Sn? So let's consider it. So we write Tn first. So Tn is given as r equal to 0 up to n, then r divided by ncr, and r can be written as 0 up to n, and here we write n minus r divided by ncr, which can be written as sigma r equal to 0 to n divided by ncr minus sigma r equal to 0 up to n, then n minus r divided by ncr. Now, from first term we can take out n because n is not changing. So Tn equal to n common sigma r equal to 0 up to n, and then 1 upon ncr minus sigma r equal to 0 up to n, then n minus r divided by ncr. Now Here Sn is given as sigma r equal to 0 up to n 1 upon ncr. So this term will be n times Sn. So we can say Tn equal to n times Sn minus sigma r equal to 0 up to n minus r divided by ncr. Now we have to prove that this term is also Tn. If it is Tn, that we will see after putting here Tn. So if this is equal to Tn, so Tn equal to n into Sn minus Tn. So we write this Tn to in LHS, so it becomes twice of Tn equal to n times Sn, and we have to find out the ratio of Tn to Sn. So Tn upon Sn equal to n by 2. But first of all, we have to show that this is Tn. So let's verify it. So now we take second term sigma r equal to 0 up to n minus r divided by ncr. So we can put the value of r. So what do we get when r equal to 0? So it will become n upon nc0. Then r equal to 1. So it n upon nc0. Then r equal to 1. So n minus 1 upon nc1. Then next one will be n minus 2 divided by nc2 till last term. When r equal to n, then we will get 0 plus 0 upon here it will become ncn. Now further, so we have Tn as Tn equal to sigma r equal to 0 to n r upon ncr. So let's see Tn equal to sigma r equal to 0 up to n and r divided by ncr. Now we put the values. So when r equal to 0, so we'll get 0 upon nc 0. This is equivalent to this term. Then plus r equal to 1 divided by nc1. Then next will be r equal to 2. 2 divided by nc2. Similarly, n divided by ncn. But nc0 is the same as ncn and ncn minus 1 is same as nc1. Hence, this term and this term will be equal and our purpose is served. Let's consider next question. Question number 3. Coefficient of x power 7 in expansion of 1 minus x square plus x cube power 6 is. So let's consider the solution. 1 minus x square plus x cube whole power 6. So 1 minus x common, x square common, 1 minus x whole power 6. So we can factorize it. So we will get 1 minus x times 1 minus x square whole power 6. So we can write it like 1 minus x power 6 into 1 minus x square whole power 6. So we can expand the two separately. So 1 minus x power 6 will become 6c0 plus 6c1 minus x, 6c2 minus x whole square, 6c3 minus x power 4, 6c4 minus x power 5, sorry, 6c0, 1, 2, this is 3, this is 4. Then next is 6c5 minus x power 5 plus 6c6 minus x power 6. And we can expand this term also, 1 minus x square whole power 6. So this will give 6c0 plus 6c1 minus x square plus 6c2 minus x square whole square plus 6c3 minus x square whole cube plus other terms, and we don't need it. So now let's see the coefficient of x power 7 in the product of this and this. So here we take power 6. So the coefficient will be minus 6c3. And since this is x power 6, so x power 1 will be multiplied. Here we will get minus sign again. So we can say the coefficient of x power x power 7 will be, so this will give minus 6c1 and this will give minus 6c3. So I'm writing 6c1 multiplied by 6c3. Then now from here x power 4, so power 3 will be needed from here in product. So coefficient will be minus 6c3 and from here 6c2. Then from here power will be 2. It means 4 power is needed from here. Sorry, we need power 7. So this is power 2. So 5 power is needed from here. So we will get minus 6c5 times, from here there is also minus sign. So minus 6c1. Now we simplify. So this will give 6c1 factorial 6 divided by factorial 5 into factorial 1. 6c3 will give factorial 6 divided by factorial 3 factorial 3. Similarly other terms. So I'm not writing those terms. So it will come out to be 120 minus 300 plus 36. So our answer will be 144 with the negative sign. Okay, now let's see question number 4. Question number 4 says if n is a positive integer, then root 3 plus 1 whole power 2n minus root 3 minus 1 whole power 2n is a rational number or irrational, but it is to be found. So let's write it. The root 3 plus 1 power 2n minus root 3 minus 1 power 2n. Now we expand. So 2nc0 root 3 power 2n plus 2nc1 root 3 power 2n minus 1 times 1 plus 2nc2 root 3 power 2n minus 2 and so on. And here we can expand this by putting one bracket. So this will become 2nc0 root 3 power 2n minus 2nc1 root 3 power 2n minus 1 plus 2nc2 root 3 power 2n minus 2 and so on. On opening the bracket, the terms containing even power of root 3 will cancel out, and we will be left with twice of 2nc1 root 3 power 2n minus 1 plus 2nc3 root 3 power 2n minus 3 and so on. Since odd power of root 3 will give irrational number, hence the expression is irrational. Now, let's see next question. Question number 5. The term independent of x in expansion of x plus 1 divided by x power 2 by 3 minus x power 1 by 3 plus 1 minus x minus 1 divided by x minus x power half whole power 10 is. So here we know formula x cube plus y cube gives x plus y times x square minus xy plus y square. The same we are going to apply here. So we write it x plus 1 can be written as x power 1 by 3 whole cube, x can be written as 1 by 3 power 3 plus 1 can be written as 1 power 1 by 3 whole power 3. So here we are expanding x plus 1. So first, so this will become x power 1 by 3 plus 1 times x square minus xy plus y square. It means x power 2 by 3 minus x power 1 by 3 plus 1. So now if we put this value here, so this term will cancel out by this term, and we will be left with x power 1 by 3 plus 1 in numerator. So I'm writing that x power 1 by 3 plus 1. Now consider second term also. Here we have x minus 1 divided by, we can take root x common. So root x common, then root x minus 1. And then here we can write it as root x whole square minus 1 square divided by denominator will remain same, root x into root x minus 1. So this will give root x minus 1 times root x plus 1, and denominator will remain root x times root x minus 1. So this term will cancel out. So from second term we will get minus of root x plus 1 divided by, here root x is left. So whole power 10. So we can write here whole power 10. Now x power 1/3 plus 1 minus, if we divide it separately, so it will become 1 plus 1 upon root x will become x power minus half, and then whole power 10. Now 1 will cancel out, and we will be left with x power 1 by 3 minus x power minus 1 by 2 whole power 10. And we have to find out the term independent of x. So let's write its general term, and then we can equate the power of x to 0. So for that, we write tr plus 1 equal to 10 cr x power 1 by 3 whole power 10 minus r times minus x power half power r. We further simplify it. So we will get minus 1 power r times 10 cr times x power 10 minus r divided by 3 minus r by 2. Now we need term independent of x. It means x power, this thing 10 minus r divided by 3 minus r by 2 must be x power 0. That is, we are going to equate this to 0. So when 10 minus r divided by 3 minus r by 2 equal to 0, so from here we get r equal to 4. It means fifth term t 4 plus 1, that is t fifth term, will be independent of x, and we can evaluate t fifth. So t fifth will be, we put r equal to 4 here, 10 c4, and then only coefficients. So here minus 1 power 4. So it will give 210. So our answer. Now consider question number 6. If coefficient of x cube and x power 4 in expansion of 1 plus ax plus bx square times 1 minus 2x power 18 in powers of x are both 0, then what is a comma b? So let's consider it. 1 plus ax plus bx square times 1 minus 2x power 18. Now we expand this term till x power 4. So 1 plus ax plus bx square times 18c0 plus 18c1 minus 2x plus 18c2 minus 2x whole square, 18c3 minus 2x whole cube plus 18c4 minus 2x power 4 and so on. Our concern is up to 4th power. So let's find the coefficient of x power 3. So from here, 1 should be multiplied to this term. Then we will get x power 3. X power 1 will be multiplied to x square to get x cube. Similarly, x square should be multiplied to x power 1. So coefficient of x cube, if we evaluate, then we will get minus 18c1 times 2b plus 4 times 18c2 times a minus 8 times 18c3 equal to 0. In our question, it is given the powers of x are both 0. So this is 0. We can simplify it. So if we simplify this equation, so we will get 51a minus 3b equal to 544. Similarly, we can get the coefficient of x power 4, and that will be come out as 18c4 minus 2 power 4 plus a times 18c3 minus 2 power 3 plus b times 18c2 minus 2 power 2, which must be 0 as given in the question. Now we simplify it. So on simplification, we will get another equation as 32a minus 3b equal to 240. We can solve these two equations to get a equal to 16 and b will be 272 divided by. Now let's consider next question. Question number 7. The sum of coefficient of integral powers of x in binomial expansion of 1 minus 2 root x whole power 50 is. So let's see. 1 minus 2 root x whole power 50. If we expand it, so what do we get? 50 C0 plus 50 C1 minus 2 root x plus 50 C2 minus 2 root x whole square plus 50 C3 minus 2 root x whole cube and so on. Here we are going to evaluate integral powers of x. So let's see, here power of x is not integral, but here since root x gets squared, then it will be integral power. Similarly, fourth power, when minus 2 root x whole power 4 will be written, in that case it will also be integral power. So we consider those terms where x is in integral power. So, and one more thing we can do, since we have to get the sum of coefficients of integral power, so we can put x equal to 1. So what do we get? We get 50 C0 sum 50 C0 plus here 50 C2 and this will become 2 square. This question can be solved by other method also. So this is giving little complicacy. So we can go other way around. It will be easier. So now let's see this way. We write 1 minus 2 root x whole power 50 equals 50 C0 plus 50 C1 and this is minus 2 root x plus 50 C2 minus 2 root x whole square and so on. And we also write 1 plus 2 root x whole power 50. So it will become 50 C0 plus 50 C1 here 2 root x plus 50 C2 2 root x whole square and so on. Now we can put x equal to 1 and we take integral powers. So for integral powers from here this will be integral power, this will not be integral power, and if we add these two, so on adding what do we get? 1 minus 2 root x whole power 50 plus 1 plus 2 root x whole power 50 equals, these terms will cancel out. So we will get twice of, from here, it is twice of 50 C0 plus 50 C2, and this is 2 square into, this will become x plus 50 C 4 and then 2 power 4 times x square and so on. Put x equal to 1. If we put x equal to 1, so we will get 1 plus 3 power 50 from it. And in RHS, we will get twice of 50 C0 plus 50 C2 into 2 square plus dot dot plus 50 C4 into 2 power 4 and so on. So our concern is the sum of coefficient of integral powers of x in expansion of this. So we can divide this. So we will get 1 plus 3 power 50 divided by 2 will be equal to 50 C0 plus 50 C2 2 power 2 plus 50 C4 2 power 4, which is sum of powers of x, where x is integral. So our answer is 1 plus 3 power 50 divided by 2. Now let's consider last question. The sum of the coefficients of all odd degree terms in expansion of x plus x plus square root of x cube minus 1 whole power 5 plus x minus square root of x cube minus 1 whole power 5 for x is greater than 1 is. So let's consider the solution. So we can expand the two expressions. So from here we will get 5 C0 x power 5 plus 5 C1 x power 4, then x cube minus 1 square root plus 5 C2 x power 3 root x cube minus 1 whole square plus 5 C3 x power 2 root x cube minus 1 whole cube till fifth power and plus 5 C0 x power 5. This term will become negative. So 5 C1 x power 4 root x cube minus 1 plus 5 C2 x power 3 root x cube minus 1 whole square minus 5 C3 x square times root x cube minus 1 whole cube. That's two more terms. On addition, what do we observe? This term, similarly, this term will cancel out. Only 5C0 x power 5, 5C2 x power 3. Similarly, 5C4 x power 1 term will be left. So we write it as twice of 5C0 x power 5 plus 5C2 x cube, and here this will become x cube minus 1 square root. So square root will get cancelled. Then 5C4 x times this will become x cube minus 1 whole square. Now, if we expand this term, we will get x power 6 minus 2x cube plus 1. And here, so we just write it 5C0 x power 5 plus 5C2 x power 6 minus 5c2x cube plus, from here it will become 5c4 x power 7, then minus 5c4 times 2 x power 4, and from here last term 5c4x plus 5c4 times this x. Now, sum of coefficients of odd degree terms. So here odd degree term is this is odd degree term, and this is also odd degree terms. So we find the sum of coefficients of odd degree terms. This is odd degree, this is odd degree, x power 7, and here this is odd degree. So it will be twice of 5c0 minus 5c2 plus 5c4 plus 5c4. So we simplify. So what do we get? Twice of 1 minus this will become 10, and this will become 5, this will become 5. So this will 10 will cancel out. So we will be left with 2, which is our answer. Thank you for watching.